Hello everyone, today I'll be showcasing PropBot's data collection capabilities. Right now my setup is very simple. I have the autonomy computer running outside of the screen. I also have a simulator running, and so simulated PropBot is moving around the map, and it's at different locations and stuff. So, but our focus today is on data collection. And so what my team has done is we've created a script that will, when started, will start collecting data as that the user specifies, and then when you stop the script, the data collection will be stopped, and all the data will be stored into a file. So what the script is called, it's called collect data, and if you run it without any arguments, we get instructions for how to use the script. But it's very simple. So the first thing we do is we add a name to the file that we want the data output to, and you can also add the kind of types of data you want to output. So for example, for us, say we want to output location and speed data, and so this will start collecting location and speed data. So it's basically listening to the ROS network and for any incoming topics to, for example, navsat fix, that's generally output by the GPS. Right now it's output by the simulator, but it always contains longitude and latitude values. CMD vel, that just outputs, or that contains information about how fast PropBot is trying to move. So we're not obligated to stay in this terminal. As a user, we can go around, look at simulations. If PropBot is out in the open, you don't have to stay and follow the program. But say now you want to stop recording, that's to stop. You can just terminate the process, and by that, all the data should have been collected. The script outputs where the data is, but it's always going to be in a file called backfiles that's in the repository. And so let me just remove the old files I have here. So we see that the files that we've just output, because we called it on demo 2, we see that there are 3 files that are output. So if we take a look into, for example, demo 2 location, we see that it's a YAML file, and it's containing the location message across the time period. You can see that the location is changing, and of course this corresponds to whatever the GPS or the simulator is outputting. The location is timestamped. Right now the timestamp isn't, it's based on what the simulator believes the time is, so the simulator kind of overrides all the times in ROS, and so that's why this is what the timestamp is. But in a real run, this would be replaced with the actual time of that at which the data is collected. Similarly, if I look at the speed, it's the same thing, again in a YAML file which is easily parsable, and so we see that the data can be looked at, it can be processed through Python, through Bash, through anything. The last kind of file that is output is this .bag file. Now this is very specific to ROS.bag, which is the sort of the API that we used. It provides some very handy features which a user can explore on their own. But essentially what it allows you to do, it combines all the data into one file, and it essentially allows you to replay all of that data and in a way publish it onto the ROS network. So if I were to play this file, then essentially all the data that I recorded is now published on the network in the same sequence at which it was recorded, and at the same time difference between each item. And so you can see how this can be very useful if you want to replay a scenario, or you want to look at data through the visualizer again. And so overall, I think these features are very helpful because they help researchers when they're trying to verify something or trying to collect data, and also they help developers when they need to debug or when they need to debug or test something.